This is the general expression for graphing a radical function. Y equals a square root of b times x minus h plus k. Just like before, k is our vertical shift, and h is our horizontal. Now remember, with horizontal shifts, if in that parenthesis you see x minus 2, that means we're going to go to the right 2. And then if you see x plus 2, that means it's left 2. Keep in mind, it's the opposite of what you see. Like before, A tells us whether it's a stretch or a shrink. And B does the same as A. So for A and B, if A is greater than 1, it's a stretch. And if A is between 0 and 1, it's a shrink. Also, if A is negative, then we reflect over the x-axis. And if A is positive, if B is negative, that's a reflection over the y-axis. So now you have two different reflections to memorize. If we have a function y equals square root of x, it's going to look something like this, where we say it increases from left to right. If we have a function y equals negative on the outside of the radical x, then it goes like this. There's that reflection. Now, this is a decreasing function when we go left to right. Remember, increasing and decreasing intervals is looked at left to right on the x-axis. And the last thing is, if you have y equals, and then you have a negative x under the radical, or a negative value under the radical, this is also decreasing, but it's on this side, it goes like this, which is still decreasing if you read it left to right. Domain and range with radical functions is a little bit tricky. So what we're going to do is we're going to actually set the guts. Now, what I mean by guts, and again, I'm going to put this in parentheses, or I'm sorry, apostrophes. Guts would be like anything in this radical right here. You're going to set the guts equal to 0, because you know that if it's less than that value or greater than that value, or whatever makes the guts negative, it can't exist under the radical. So if we set it equal to 0, it allows us to see that value that it can't be, or the domain that it can't be. And then something else that you have to do is you have to look at reflections separately. So those two things are going to help us identify the domain. And then when it comes time to identify the range, you're going to look at vertical shifts, which is our k. And then you're also going to look at reflections. So we're going to do some practice finding the domain of 3 examples. So here's our first example. The square root of 12x plus 24. So we're going to set the guts inside that 12x plus 24 equal to 0 and solve. Equal to 0. Okay, so x equals negative 2. So it's allowed to be negative 2 because that gives us 0 in the denominator. Or, I'm sorry, it gives us 0 under the radical, and which we can take the square root of 0. But it can't be, we're going to go to infinity. It can't be less than negative 2, like negative 3, because you know that that would give you a negative value under the radical. All right, example 2. All right, 3x minus 2. If you set that equal to 0, all right, again, you can have 2/3. That's why I'm using a bracket. And we're going to go to positive infinity because it's allowed to be everything greater than 2/3, just not less than 2/3. All right, our third example is 2 minus 3 times x plus 1. Okay, so we're going to set this equal to 0. First thing I'm going to do is distribute on the left side and then add like terms. Okay, so now in this case, if you were to plug in a value, you can always test a value to see whether or not it can be less than negative 1/3 or greater than negative 1/3. So you can always test a value and see, but this one actually is allowed to be every value less than negative 1/3. So it's written like this. If you're not following where the infinity sign goes, whether it can be greater than or less than, test a value, like I said, that's less than negative 1/3 and greater than negative 1/3, and see which one gives you a positive value under that radical, and then that's the side we want to go to. So in this case, we're going to go to the left side of the number line, lower and less than negative 1/3. Okay, so we're going to do just one graphing problem, and then we'll do more in class. So we're going to start with y equals x plus 2 under the radical. Yes, they will get more complicated than this, but, let me also make this plus 5. They will get a little bit more complicated than this, but I just want to show you one, and we'll do more practice in class. So the shifts here would be up 5 and left 2. All right, so you would have to identify the domain and range, and our domain is allowed to be negative 2 and greater, bracket around negative 2. And then our range is going to be 5 to infinity, because the parent function of a radical starts at 0, 0 and goes like this. So if I'm shifting it up 5, it's not going to go lower than 5. All right, so let's solve for the x-intercept. So we're not actually going to have an x-intercept because, as I said before, we have a vertical shift of 5. So we're going up 5 from 0, 0. So we're not going to actually have an x-intercept. All right, so let's move on to the y-intercept. Need some more space. Okay, so in the y-intercept, x equals 0. So you're going to have y equals 0 plus 2 under the radical plus 5. So y equals the square root of 2 plus 5. And if we estimated this, you're going to get a value of 6.41. You might also have to solve for some other points. You can easily pick any x value. So say we did 2. 2 would be a good value to pick to plug into this equation, because we actually, what is 2 plus 2? Well, that's 4. And then what is the square root of 4? Well, the square root of 4 is 2. Add 5, so then you have a nice value of 2,7. All right, so with all that on your paper, I had to erase to get some room, but I'm going to go left 2 and up 5. and I think like it's about right here. My my y-intercept was 0, 1, 2, 3, 4, 5, 6, and a little bit above that. And then let's say we also did 2, 7, that'd be somewhere up here. So my radical is going to look something like this. Again, this is a sketch, but this is what it would look like. We're going to do a lot more practice with graphing, identifying domains. They get a little bit more complicated than this, but we'll do plenty of practice in class.